we're asked to solve this system of equations. And actually, I'm gonna do it twice. I'm gonna use both the substitution method and what I like to call the elimination method. If you're watching this video as part of our course at Alamance Community College, our textbook author, Robert Blitzer, actually likes to call the elimination method the addition method. And we'll just learn that those are synonyms, and I like calling it the elimination method. But to start off with, this system isn't what I'd consider in standard form. I want to make it look like all the other systems I'm used to. So I'm going to rearrange both equations so I see an ax plus by equals c. So in this first equation, I'm going to add 2x to both sides, making my first equation a 4x minus 3y equals 8. In this next equation, I'm going to need to take x away from both sides and 3y away from both sides, revealing this equation to really be 2x plus y equals 14. And this is the equation I want to solve. And I think it's actually a good idea for you to pause the video here, because maybe you have a gut feeling about which method would actually be the better method or the easier method, or just the one you feel like doing right now. So pause the video here and see if you can choose a method. Okay, so I'm thinking a lot of you probably chose substitution. So I'm going to solve this by substitution first. If you chose elimination, your author's addition method, that's fine. We're going to do that in just a moment. But looking at this, I think substitution might be a good choice because I see a 1 times y. So if I take 2x away from both sides of this second equation, I get y equals minus 2x plus 14. And now I can substitute that in for this y. 4x minus 3 times that value of y, 2x plus 14, is equal to 8. So now I need to distribute and just solve this linear equation that now only has one variable in it. 4x plus 6x, and let's see, minus 3 times 14 is minus 42, is equal to 8. I'm going to add 42 to both sides, making that an even 50 on the right-hand side. 4x and 6x add together to give me 10x. Dividing both sides by 10 reveals that x is equal to 50. Oh, x is equal to 5. All right, so now I can actually use this equation that says y equals to find y. Plug 5 in, I get minus 2 times 5 is minus 10, plus 14 is 4. And there is my solution to this system of equations. And I can always think about that as the point of intersection between these two lines. Now, some of you might have said, hey, I like the elimination method, that addition method. So we have the same system. We'd always write it in the standard form first. And maybe if you were thinking to use the elimination method, you thought that you could multiply this bottom equation by 3. And that way you'd have a minus 3y and a positive 3y. So the top equation could stay the same. Now I need to distribute that 3. Now I add my equations. And I find out that 10x is equal to 50 again. So x is still 5. And I could use either equation to find the value of y, but I like that 2x plus y equals 14. Plug in that 5, I get 10, take 10 away from both sides, and y is still 4. So there we have it. We've solved this system of linear equations using both of the methods we know, substitution, and then now the elimination method, which your author calls the addition method.